Welcome back to Ed Leedskalnin's workshop. Today we're working on some DC voltage. I'm oscillating a transistor straight out of the 24 volts into this iron ring. I have a copper coil in the middle. And I got my voltmeter. I'm going to show you guys something. These have been studies that I've been working on, and it's about induction, but it's about induction with pulses. And on top of that, it's about radiant energy. Now I want you to see that I'm pulsating this iron bar. Picking up something in the middle there. I'm going to go ahead and stick this at the bottom, and you can see right now we're at 3.8 volts, and here's the other end of the voltmeter. Okay, so what I'm picking up is air, but I want to show you something. Watch my finger. I'll put it over here and watch the voltmeter. 8.63 volts. Watch my finger. Look at the voltmeter. So, a couple things I wanted to touch base with you guys on. When you're messing with Tesla coils, slayers, any pulse circuit, any DC, it really comes down to the wave that you're sending, and it's the front of the wave. The front of the wave really has a lot to do with everything. Now, I'm just going to say that because my experience so far with different types of frontals on the waves, I noticed a big difference, and I just want you guys to know out there, you could, when you pulse, you can pulse real fast, and you're not letting a good kinetic stick to that pulse, and you're going to see a pointier wave, almost like a needle. And you'll notice also on an oscilloscope, when you hold on to it, you'll get more of a flat square on the top. And it does it. I'm telling you, it does the magic. So here we are back to my little induction setup here. And you can see the voltmeter. I got the negative end up in the air. Positive is coming off the bottom side of that coil, which technically I guess I should take this, which is coming off the base of the transistor. I'll put it at the bottom here, sort of like I do my Tesla coils, because you want that to flow upward. And right now it's this base here that's opening up the transistor. It's the signal input. It is what's telling the transistor when to open and shut. Pretty cool stuff. So I want you guys to dig out your stuff and start experimenting with. To get that transistor to go on and off, you need to pulse, and then you need to put a signal into something. So I just want you guys to see it on a small level. So right here, there's our volts. I'm going to grab the voltmeter right here. And you can see, just put it up in the air because the radiant energy, I'm getting 1.4 and change. And watch my finger. Jumps up to 3. Even better. Watch this, I'm going to stick it on the ground. As soon as I touch the ground, it goes up. Now it's up in the air. Now my finger's on it. This is an important video for you guys out there just starting with this Slayer or pulse circuits. It's really good to know that if I put the pulse into the copper coil, nothing shows up on the metal. But if you put it in the metal, it definitely shows up on the copper. Definitely shows up. So I think there's some really strong importance to using iron to really make a difference. But you guys leave some comments if you have any. My finger. Virtual ground. So that means anything could be virtual ground. Anything that's matter becomes virtual ground.